also governed by the other parameters such as the magnitude of the incoming velocity and the kinematic viscosity of the or the coefficient of viscosity of the flowing fluid. Incoming velocity উপর depend করছে boundary layer growth. Obviously the velocity will change the boundary thickness. We should not consider the boundary layer thickness. When the velocity changes is minimum, that is 1%, then we consider the boundary layer thickness. For higher incoming velocities, there would be a less time for viscous force to act, and accordingly there would be less quantum of boundary layer thickness at a particular distance from the leading edge. When the velocity is high, there would be less time for viscous force to act, and accordingly there would be less quantum of boundary layer thickness at a particular distance. When the flow velocity is maximum, then initially at the initial condition the flow become turbulent. So what do you mean by the turbulent flow? That means velocity will change. So at the when the initiation the velocity will change, then the 1% limit is stopped within a certain period, within a certain length. Okay. Hello.
স্যার বুঝলাম না স্যার।
When the velocity will increase, that means the velocity will change. That means the velocity will change abruptly. That means the flow become turbulent. That means the flow become turbulent. So that means the flow become turbulent and the velocity will change abruptly. That means the limit is minimum. The 1% change in velocity will occur in a short distance of x. Change in a short distance of x. That means from the diagram, that is a distance of x, and between the distance x, that is a 1% change in velocity. And when the velocity will maximum, then the it abruptly changes the velocity. That means it changes the turbulent flow at the very initiation. Then the length x will reduce. You understand this? The length x will then reduce. Okay. More turbulency means the x will reduce, and less turbulency means the length x will increase. Okay. Okay. So for some distance from the leading edge, the boundary layer is laminar. We have already described in the diagram. For some distance from the leading edge, the boundary layer is laminar and the velocity profile is parabolic in character. Flow within the laminar boundary layer is smooth and the streamlines are essentially parallel to the plate. Laminar means the fluid particles will flow parallelly, that is streamline flow. We already know that. Subsequently, the laminar boundary layer becomes unstable and the laminar flow undergoes a change in its flow structure called transition. And from the transition, after going to a transition zone of finite length, the boundary layer entirely changes to turbulent boundary layer. That is shown in diagram. First is laminar boundary layer, then is turbulent transition boundary layer, then is turbulent boundary layer. Okay. So the pattern of flow in the boundary layer is judged by Reynolds number. Okay. Where x is a distance, we know that that is the kinematic viscosity mu. Okay. The x or L we have or D. তাই তো লিখি এখানে Reynolds number rho Vd by mu. Rho Vd মানে কি V into D by nu. So that is nu. আর এখানে L ও লিখতে পারি, ডিস্টেন্স বা ডায়ামিটার, সো লেন্থ ইজ দ্য x। ওকে, the transition from laminar to turbulent pattern of the flow occurs at values of Reynolds number। ওকে, Reynolds number উপর ডিপেন্ড করবে, আমরা সবাই জানি। In the laminar boundary layer, the velocity gradient becomes less steep as one processes along the flow. Okay, it is because now the change in velocity from no slip at the plate surface to free stream value in the potential core occurs over a greater transverse distance. Nevertheless, in a turbulent boundary layer, there occurs an interchange of momentum and energy because the velocity will change in case of turbulent boundary layer. So momentum or energy will change. What do you mean by momentum? Mass into velocity. Okay. Momentum, mass and velocity. So in case of turbulent flow, the velocity will change. That means momentum will also change. Okay. So this is the curve, laminar boundary layer and turbulent boundary layer. So that is the along the x-axis u by u0. U means final velocity, u0 means initial velocity, and y, that means displacement by the delta, that means boundary layer thickness. When we draw this curve, we get that laminar flow. In case of turbulent flow, we get this curve. So which one is the more parabolic? Which is the more parabolic? Hello?
Turbulent, sir.
Turbulent flow is more parabolic. We can see from this diagram that the turbulent flow is more parabolic. And when we draw the curve between the distance from leading edge, that is x, and the wall shear stress tau 0, we get this type of curve. Okay, from when the laminar flow, then the shear stress is maximum, and in the transition zone, the shear stress will minimum, and after the turbulency, the shear stress will increase and gradually will decrease. Okay. Okay. So now the boundary layer parameters. First is the boundary layer thickness. We have already told that which is the boundary layer thickness up to the limit of change in velocity 1%. That is the delta. Here that is shown in the diagram. That is the boundary layer thickness. Okay. So that is the delta. Delta is the boundary layer thickness, which is shown in the diagram. Okay, and the inclination, when we get the tangent from the curve, that is called the delta dashed. Okay, that is the delta dashed. The change in inclination we can get from the tangent of the curve, that is the delta dashed.
Yes.
Okay.